Yeah, we didn't even need it. Okay, so finally we're starting. For real this time. Let's see, how late did we end up being? 33 minutes. Okay, well.
That's about 30 minutes. We can say that it was...
that was setup time, yeah.
Yes. Sounds about fair. That sounds fair.
Okay, so I'll go over my first point again. So this is the longest running project I've ever worked on. And it is definitely my longest lived Rust project by a very wide margin. And so most of what we need to talk about for me to explain like what Odilia is, how does it work, most of it is actually explaining all the systems that connect to it, because none of those systems are familiar to your average web programmer, let's say. Right? When you show someone the abilities of Axum or Rocket or Django in Python, you can assume they're already familiar with how forms work, HTTP, HTML, CSS, and all these things. You assume that they know all of this before you start talking to them. Now, for a screen reader, a lot of times everything one level lower is also completely foreign, and no one's ever heard of it. So we sort of have to explain two layers. It's essentially accessibility infrastructure, and then accessibility programs like a screen reader. So we'll start with my notes here. So what the heck is a screen reader? Like, what's the point? Why would I need one? So a screen reader, instead of dealing with, pixels and X and Y and, you click your mouse here or something, instead of that, the computer will tell you what is on the screen, and you can decide what to do based on that. Right? Now, if you want to go to the next item in a page, for example, you might hit tab. Right? Tab is how you generally get to you get to the next focusable thing. So a button, a text box, link, anything you can click, you can get there by hitting tab. So it's essentially a way for you to navigate with your computer even if you can't see it. Now, the primary use case is people who are blind or visually impaired, but your machine itself often thinks more in accessibility terms, more in nodes and objects and stuff like that, rather than pixels, right? Pixels is just an output mechanism. So the important thing to understand from an accessibility perspective, and this is true across operating systems, is that everything is a tree. So your desktop is your root node, and every if you use virtual desktops, each virtual desktop is a node underneath that. Each window is a node underneath that. Each tab in a browser is a node underneath that, and so on and so on. Headings, sections, navigation bars, links, they're all sort of nested in this hierarchy. So when you're looking at a big tree like this, you're going to want to get around somehow. You're not just going to want to navigate one by one, right? Okay, well, that's a window frame, and then I'm going to look at the page frame, and then maybe, I don't know, what would be after that? Maybe the heading of the website, and then the main, and I want main, I'm going to go to the next heading. Like, you don't want to jump through all those hoops. So generally, when you're using a screen reader, you end up navigating by role. Now, role is essentially a type. If you've ever seen area-role in HTML, you can think of it kind of like that. So I want to go to the next button, or to the next heading, or to the next something, image, form, table, whatever. So this is called structural navigation, and this is a lot of what screen reader users do, and we'll actually talk about how Odilia is optimized for structural navigation later. Okay, so let's start with the most simple thing. If a screen reader talks to you and says stuff about your screen, then how do you talk on Linux, right? How do you make sounds that people are hearing? Well, we can start with eSpeak. Has anyone ever heard of eSpeak before? I'm going to assume probably not. So eSpeak is a classic, old school speech synthesizer. Yeah, it's pretty hard to understand. I can go out of my terminal here, and I'm going to run eSpeak
I don't see.
hello. No, you won't be able to see this. I'm leaving my notes on the Discord. Okay.
Hello. Hello, my name is Diot.
Oh wow, it says you're okay.
Okay. So I don't know if those of you on Discord, did you end up hearing that? I'm not sure. But it's basically this very old school robotic voice.
Jaden did.
Oh, Jaden did. Fantastic. So that's sort of the old school way. eSpeak is very mature. It has language support like across the world.
Hundreds of languages.
Yeah, you will see like rare dialects of Chinese supported fairly well
Is
with
it
eSpeak.
cross-platform?
It's cross-platform. Yep, it'll run anywhere. It'll run on your phone. It'll run on
And
Linux.
it's
It'll run on
very,
Windows.
Very, very fast.
Yeah, it's very responsive, which is nice, right? There's some benefits there. It's written in C, so it's very old school,
And it's small too.
and it's very small. You can include it as a linked library or even a static library if you wanted. It's pretty small. After that came Festival. So Festival was meant to be the second generation open source language model, and it's okay.
Is it a typo there, or is it intended?
Oh, yes, there is supposed to be a T there. Yeah, there is supposed to be a T. You're right. So yes, so there's Festival. So that was meant to be second generation. It's supposed to be quite a bit better, and it is better in a lot of ways. And I can't show you because it doesn't work on my system, which goes to show you how good it is. So Festival was written in C++. It had a lot of buy-in from, I believe, Carnegie Mellon University, and I think they put a lot of stuff into it. But frankly, at the end of the day, any individual voice or any individual backend is terrible to work with, because if you want to switch voices, you now have to change your library. You have to change all the calls to say, right? Instead of say, it's going to be speak. Does this system have priority levels? Can you cancel things that you were halfway through saying? I mean, there's all these features that you might need, and they might be supported in one and not the other. It gets messy. So, Linux has something called Speech Dispatcher. Now, this is essentially a system that you can talk to as a client, and it talks to the individual voices on their own. So it uses a protocol called SSIP, which is Speech Synthesis Information Protocol. I don't know, I forget what the I stands for, but I think it's information. The point here is that this protocol allows you to say, okay, I would like this voice to say this piece of text at this speech rate. So I want it to be quick. Or I want it to be slow. Or I want it to be high-pitched, right? You can change all of these settings in a generic way, and then Speech Dispatcher will talk to each of the voices individually, whichever one is selected by the user. Now, Speech Dispatcher is cool because it's generic. It even allows you to use proprietary voices. Now, you might be thinking, Tate, this is Linux. We don't do proprietary. But listen to some of the voices you can get. So I'm going to unmute myself again, and let's see if it'll say this out loud. Oh, that's really fast.
I want to slow it down.
Is there a speech rate?
There it is.
Sounds like commercial. You know, in that of any TV or ad, there's like disclaimers.
Yes.
Yes.
Yes, exactly. So there is... okay. There's a flag I can use here to slow it down.
Well,
Okay, I can slow it down even further. Maybe some people on the Discord will be able to hear it.
Hello, my name is Tate.
so basically the level of voices that you would get on your, like, any voice assistant on your phone or any, like, I don't know, Google,
Yes.
whatever.
So if you used Siri before, the Siri voice can be purchased and used through Speech Dispatcher on Linux. It is proprietary, but because it works with Speech Dispatcher, you only have the voice as the proprietary component. There's still an open source protocol on top of it. There's still a way to like integrate with any screen reader, any speaking, anything you want to do, you can do it through this protocol. So I think it's good, and it allows you to have choice as a user, which is great. So I have modified an already existing library called SSIP client, and I've added essentially Tokyo async on top. So they had a version that was synchronous, but I just added a few extra features, and now that's a crate you can get on crates.io, SSIP client async. This allows you to construct SSIP commands and then send them over a socket, and then you will get a response back saying, oh, this worked, or this failed, or hey, I'm going to speak your text right now. Okay, so that's all speech. Everything we talked about, that's just saying stuff. But what about receiving events? We happen to know that for a screen reader to work properly, you're obviously going to need to know, okay, well, when has the user focused on a new item, right? If you're focusing on a new item, you might want to say what that item is. Or perhaps you're typing some text. Sometimes on every character, but sometimes on every word, you might want to say, oh, like you just typed blank, right? So there's all sorts of times that we're going to want to say something for a particular reason, or maybe something on the page is updated, right? If you're ever playing a game online, like let's say you were playing chess and someone moved their piece, well, you wouldn't want to have to try to move somewhere on the page to find if they moved or not. You would just want it to announce it immediately, right? So there are ways to do that. So we want to respond to events. Now, there's a couple events here in the notes that I've mentioned. So there's a state changed event. So this will tell you whether an element is hidden, if it's visible, whether it's active, enabled, expanded. So think of like a summary and details tag in HTML, right? Is it expanded? A menu, perfect example. Is it selected? So you can actually find out, has the user selected, is this item currently selected by the user? Is it focused, etc., etc. Then there's property changed. So this is, again, other information about an object, but these have a value. So instead of a state is hidden or visible, active, not active, enabled, disabled, expanded, contracted. With properties, they have values. So think of like length. You know, in HTML, you can set length on an input field, and you can't type further than that, right? So if that were to change at any time, this is actually an event that would get transmitted to us. There's text changed. So if text is inserted or removed anywhere in the entire tree of all windows you have open, we can hear about it as a screen reader. Children changed. So this is how we add and remove nodes from the tree. You get a children changed event. It might be the add or remove kind of event, and it will either contain information to add the new child to the tree or just an index to remove. Either way. Also, keyboard and mouse clicks and presses. These are also handled through the accessibility bus. Or through ATSPI, and we haven't talked about what that is yet. But there is a note in here for later. That's obviously a huge security risk, but on top of that, it's complicated because of Wayland. X11 had a system that worked for a very long time, and now Wayland's messed it up. But anyways, now these events are transmitted through an API called ATSPI. Assistive Technology Service Provider Interface. What a wonderful name. Sounds right out of Oracle, doesn't it? So this is essentially a specification for how to talk over dbus. People who are very familiar with Linux will have no problem with dbus. But to quickly give you information about it, it's essentially an object-oriented communication mechanism. So if you're familiar with how Java works and you think in terms of Java, then dbus will totally make sense. There are interfaces, there are objects, there are properties, there are methods, there are fields. All the things you would expect from a Java interface. ATSPI, I believe, was originally written, or dbus was originally written in Java or something like that. So I think there was some overlap there. But if someone knows the history, feel free to correct me. There's a few command line tools you can use here to get familiar with dbus. So dbus monitor and busctl. So busctl is how to run something on dbus. So you say, well, I'd like to call this function. And dbus monitor will just print out everything that's happening over dbus. Now I have a cool script to show you. And I'll show the Discord this one as well. So I'll go to Odilia scripts. This script is called sniff A11Y bus. A11Y is a common contraction of accessibility because no one wants to type that whole word out all the time. Now, if I run this, you'll see that there's a few events, right? There's a couple, but we're able to scroll to the top, right? So maybe 15, 20 events. Now, I'm going to save this to a11ylog.txt. Then, I know you can't see me doing this, but I'm going to open Firefox. Okay? Give it a second. Firefox has been slow to open on my computer lately. Not sure why. I could use another app. I don't have to use Firefox.
Yeah. Use your use Discord then.
Ah, Discord uses an old version of Electron that will not work.
Yeah.
Yeah.
Does it work with Calgary?
I don't think Towery has accessibility support yet. No. I don't know of any Rust GUI library that currently supports accessibility. It is on the roadmap for all of them. It is not done for any of them. Yeah.
I see.
That sounds like a trampoline.
Mm-hmm. Okay, Firefox, I actually need you to open. Okay, well let's use a different application. Pavu control. Those of you on Linux certainly know what this is. It's essentially a microphone editor, not microphone editor, like audio settings manager thing. It's an independent project. It's not the GNOME settings window or anything like that. It's its own app. Now, I'm just clicking around in here a few times, right? I have done nothing substantial. I'm just hiding and showing a few elements. You're seeing this volume slider bounce up and down. Okay, well, let's say I'm done there. Now, if I come back here and I stop my script and I open it, now Firefox opens. Thanks. Now, if I open the a11ylog.txt, okay, there were only, let's say, in this case, 82 lines worth of information. Okay, well, that's not so much, right? That doesn't seem so bad. Let's do it again with Firefox, because Firefox is the perfect example of something that floods your accessibility bus. So we'll go to example.com, and then we'll go to rust-lang.org. Okay, so I've visited 2 websites, and then I'm going to close those tabs. And then come back. Okay. Actually, hold on a second. am going to have to restart Firefox. There we go. Okay. So we'll go to example.com, rust-lang.org. I'll explain why I had to do what I did in a second. Okay, now we'll record it. So example.com, rust-lang.org, and then close the tabs. Okay, now if we look at this, and I turn my line numbers on, that was 618 lines. Okay? And if you are on an interactive website that loads with JavaScript, this will be 60,000 lines. Load one web page with JavaScript, you will have 60,000 lines of input and output over this bus. Okay. Now that's important to remember, and this whole side tangent was only so I could show you how much garbage gets put through here. It's not that it's garbage information, we want to know it, but it's important to know how full this bus gets. Like, we really do overwhelm it. Okay? Now, let's go a little bit further. Right. So, there's a reason we're using Rust, and it's because of this huge data transfer over this dbus protocol, right? And the current major screen reader on Linux, which is Orca, this is not in my notes, the current major screen reader on Linux called Orca, that one is written in Python. And you can imagine that Python, once in a while, might have problems keeping up with 60,000 events in a second, or in 10 milliseconds.
Yes.
Yes. Yeah. Well, everyone has had an experience at some point, right? So when all these objects are transmitted over dbus, right? So we ran a script there that collected all the information that was coming in over dbus. Now, every object that gets sent is in a pair. So its ID cannot be universally unique. And there's a reason for that, because we would have to synchronize IDs across applications. So every time any application wanted to register an object, so think of that like a semantic tag in HTML. So nav, anchor tag, button, form, table, anything that has meaning. So anything except for like div and span, basically. Anything else, anytime you add that, you don't want to have to like check in with the accessibility daemon and be like, hi, I would like ID 777, and it says, oh no, that's already taken. You're gonna have to go up a few, right? Could you imagine how much that would slow down your apps? Like, that would be disastrous. So every ID, every object has two IDs, the application ID and a unique ID, quote unquote unique. It is unique for that application. So our caching system for Odilia is essentially just a hash map that maps from the bus ID, or the application ID, let's call it that, the application ID and the unique ID given by the application, right? And then it just returns a cache item. So a cache item is essentially all the information we believe we are going to need immediately about any given object.
Do you already have document comments about it?
We have very detailed comments about this. Yes.
Awesome. It may be just easier to show it this way.
I can show you that. Sure.
Yeah.
So let's do that here. Odilia cache source lib. As you can see, we have a bunch of very nice clippy lints over here. And we also don't allow unwrap. That's a very fun clippy lint that you might not know about, is you can lint on unwrap. You can also see that we're importing a ton of dependencies here. Okay, some of this stuff is from our own crates. Some of this stuff is from the standard library. Some of it is from the ATSPI crate, which we also maintain. Lots of stuff here. So then, I don't know if these comments will fully help you make the distinction, but the accessible primitive struct is essentially a unique ID. This could be renamed unique ID, and it would have the same meaning. This is a combination of both an ID, like 1, 2, 3, 4, 5, and a sender. And this sender is the application ID. So where did this come from?
And ID is a string.
Both things are strings, but the sender is almost always 4 characters. It's almost always 4 or 5 characters. So we've used smart string here, which puts a string on the stack unless it exceeds 21 bytes. And then it'll put it on the heap again.
I see.
But the ID is often very long.
Jane asked, why are the IDs a string?
Yeah, so the ID is technically a path. This is the problem with dbus. So the dbus communication method to reference unique items, instead of giving it a number, you actually give it a path, and that could contain a unique number. So often you will see something like this. So example would be org A11Y ATSPI accessible 1, 2, 3, 4, 5.
Yeah, maybe you can even make it an actual comment because...
Yeah, I probably should. So that's one example. You know what? I should just put examples.
Yeah.
Okay? Now the issue here is that you can also get stuff like this. Org GNOME GTK and then some
Cache.
and then this would be a UUID.
Uh-huh.
Now I know that that's not proper UUID format, but the point is that this string can technically be anything. Legally, it does not have to follow any format. It is only a convention that it follows the format that we originally accepted.
I see.
So when we were first starting out, we actually did use a number here. So this ID was just a number. It was an I32, right? Well, then we found out that there's some special values. Okay, so turns out you can have org A11Y ATSPI accessible null. That's right, you can just have a null there. Thank you, null. Turns out there was another exception. We couldn't just say option I32. No. There's also root. That's another special value. Okay? Now, root means you've reached the top of the hierarchy. It means essentially that you are at the application, right? Because each application handles its own nodes. So once you get to the top of an application, you can't go any further up.
What about having enum?
Aha. Well, we tried that. Then we found out that there's this syntax, right? This one here with the UUID. Once we figured that one out, we were like, okay, well, we've got to do something about this. And then we went to the people that actually wrote this code here, so the ones that give us a UUID, and we asked them, well, can we depend on you to always finish this with a UUID? And they said no. They said, we might change this in the future. The format might change in the future. We might do anything with this string, and we are allowed to. So you can't stop us. And we were like, fine, we'll just use a string. So we gave up. We tried our darndest. But in the end, we decided to just use a string here. So as you can imagine, this isn't great for cache coherency. Cache coherency is not very good when you have 2 separate strings as your ID or as your key. We're working on it. We do have benchmarks, and right now we're happy with where they're at. At the moment, we can handle, I believe it was 25 to 30,000 elements per millisecond. So right now we've got a good enough speed, but we have someone on the team at University of Washington in Seattle, and they were talking to us about helping out. So
That is perfect.
yeah, we have lots of stuff here. Anyways, sorry, very, very big tangent there, trying to explain the ID system. Does everyone understand the ID system,
Yes.
though? I haven't lost anyone there. I'm hoping there's a Discord person that'll... Okay, I'm just going to go on.
No questions so far.
Okay. So, the next part is input. So, we have events that are coming from the system. So, these are events like, well, you finished loading a page, or we're adding a new item. And we have things like speech, which is like an output. But there's one thing that we haven't talked about yet, and this is stuff like keyboard and mouse. So here's the problem. Accessibility in Linux has a very fragmented ecosystem, and originally, when it was just X11 and GNOME was the primary desktop, there wasn't any fragmentation because everyone just used GNOME, right? If anyone remembers, let's say, I think it was almost 10 years ago now, when everyone just used GNOME, and they're like the only people that used anything else were nerds, right? Now it's a lot different, right? A lot of people are using Mate, or they're using I don't know what Ubuntu ships with anymore, but people are moving towards Wayland, or a lot of techie people, like their tiling window managers like i3 or Sway. And as that happened, we needed a more generic way to get keyboard events, because originally this was just built into GNOME. So they came up with one for X11.
James asks,
Yes.
how about using tile managers?
Yes, me too. You might notice, I don't know if you can tell, but you might be able to see that I'm on a tiling window manager right now. So I understand. Now, X11 had their solving point. They said, well, here's what we're going to do. Every application that wants to implement accessibility should handle all key combos as if they might be accessibility combos, check if they are, and then do everything else. So if someone hits, let's say, a key combo in a game, that application would have to check first, hey, could this possibly be an accessibility key binding? And then if it wasn't, it could continue into its logic. Okay, and if you're thinking that sounds terrible, you're right. This was terrible. We needed an implementation for Qt, GTK, what's the main, there's like a Python GUI framework, Tkinter, I want to say.
Yes, Tkinter.
Yeah, okay. All of these needed to implement their own accessibility stuff on top of all their normal key handling capabilities. As you can imagine, the accessibility developers hated this. They knew this was a terrible hack, and they knew that there would be less accessible apps because nobody wants to implement that. That sounds terrible. And it was. So we are coming to the point where there is a new solution now. The blame, or not the blame, the work is now being shifted to your desktop environment, window manager, what's the other one? I don't know. Window manager, desktop environment. It's being moved there. So now in X11, if you use accessibility key bindings on newer applications, right? Qt5, GTK4, stuff like that. What's actually happening is GNOME or Mate will interrupt those key bindings before they even get to the application, if they match an accessibility key binding. Now, the issue is that this doesn't work in Wayland, because Wayland has a completely different system of input. It has a completely different selection of responsibilities. So you might be wondering, okay, well, what's Odilia gonna do? Okay, well, we tried first to be like a good piece of accessibility infrastructure. We were gonna interrupt keys ourselves. We were gonna have no middlemen. We were gonna talk directly with the kernel, and every time we received an input event, we were gonna try to handle this. That was terrible. If anyone thinks that they should be interrupting key bindings from the kernel and trying to figure out if that matches a key binding, don't. Please do not. This is a terrible road that leads to madness.
Can you explain why?
Yes, I was just getting there. We had the most ridiculous bugs that you could ever think of. So we had bugs where keys would infinitely repeat themselves. And do you know how we got those bugs? If you set, so let's say we set a key combo like Control S, and then you hit S and then Control, S would just be repeated forever. Yeah, fun, right? The other issue is that a lot of libraries that do this for you, right? We even used a library. This is with using a library. This wasn't even like homegrown or anything. If you use a library, most libraries will not allow you to use the caps lock key as a modifier. You might be wondering, why on earth would I want my caps lock key to be a modifier? Well, in accessibility world, in screen reader world, caps lock is a very common key to differentiate accessibility key bindings from general system key bindings.
Insert is another one, by the way.
Yeah, so Melody's right. So sometimes you also use insert, but caps lock is very common. So Control A selects everything. Caps lock A might do something with your screen reader, right? We don't want someone using a screen reader to have to hit like Control Alt Shift P. Right. Realistically, what we want is someone to be able to do caps lock P, because we know that caps lock will not be used for anything else. Again, the issue here, most libraries don't support that, so we had to take a library and modify it on top of everything else. It was disastrous. It led to so many strange errors, and it was hard to debug because all these events are coming from the kernel. You don't even know like what application is focused. There's no other information. There's just this key code was pressed. This key code was released. Yeah. So that was a whole, we tried and we decided it wasn't for us. So right now, Odilia has no key combos at all, which is bad. But this summer, I have a very nice person in the US that is going to pay me to fix this problem. He is as sick of this problem as I am, and apparently he's rich. And so, and so I'm being sponsored this summer to add a Wayland protocol for interrupting key combos on the fly. Now, this would never have to be implemented by Odilia itself. There is there's a proper accessibility framework for registering key combos and having them available as like accessibility key bindings. This is something that already is a standard. I will just be implementing the Wayland side of it. So now this will work on X11 and Wayland.
20 minutes.
20 minutes. Okay. So we're looking for September, October this year. Hopefully that's when it's implemented. Blah, 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 caching. That doesn't matter. We talked about that already. Okay. So when we created Odilia, the basic framework of what we were doing is essentially we wanted a web server. If you think about it, a web server is almost a direct one-to-one comparison to a screen reader. A web server accepts one request from a client, then it goes and does a bunch of stuff in the background, hopefully asynchronously, and then pushes a bunch of data back to that client. Very much like that, we receive a key combo from a user or an event, perhaps from the system. We go do a bunch of things. We reload caches. We decide if something should be said, and then we speak it back out to the user. So Odilia, right from the outset, has meant to be an event-based system, much like Node.js. That's sort of the original inspiration, is Node.js. We'll also have a command line tool called Odilia CTL that will essentially allow you to run actions on the screen reader from something else. So if you wanted to like script your screen reader to go do something for you, you could make it do that. This is kind of how Selenium works. If you've ever used Selenium for web testing before, this is kind of how it works. It doesn't use a screen reader, obviously. It talks directly with the browser, but it's a similar idea. Also, plugins. So we want to do plugins, but we have no idea what we're doing. So if anyone has ever implemented a plugin system before in anything, literally anything, if you've done plugins before, we want to know. Because, okay, Dimitri's putting his hand up. So I don't know how this would work, especially Rust, right? It's a compiled language. How do we weave in plugins and native functionality? There's all sorts of questions there, but apparently Dimitri knows the answers.
Not really. I did it with a weird language called HK.
Oh my god. Okay, well, we're going to have to... We'll talk about that in a minute. So Odilia is technically currently functional. And as long as everyone in Discord is muted, then I can show a quick demo. Let's see if the demo gods are with me today. Okay, it's very fast. Let me see if I can... I should probably try to change that first. Config speech dispatcher. Yeah, speechd.conf. And I do not need sudo because that is in my local folder. Rate not found. Oh, come on now. Capital R rate. There we go. So we'll put it at 25, which is pretty slow.
Very slow, by the way.
Welcome to Odilia.
Okay. Hopefully people in Discord can hear that. I think I can turn it up a little bit. Oh. What did I do?
Hi.
There we go. Okay.
Welcome to Odilia. Solstice Quick Connect. Document comment panel. Solstice search with DuckDuckGo or enter address. Entry.
Okay. I'm in Firefox. I know the Discord can't see the Firefox. I am going to navigate to my own personal website, and then I'm going to hit Tab, and you're going to see what a screen reader is like.
New tab. Home take tag. Document web. Home. Link. Blog. Link. Ideas. Link. Links. Link. Ideas. Link. Blog. Link. Blog take tag. Document web.
Do I have
No.
Carrot
Push button.
browsing on?
Blog
There we
take tag.
go.
Blog take tag. Document web. Blog. O. G.
Okay. So once I'm on any item, I can then use my arrow keys to like move around it.
G. O. L. Capital B. Blog.
If I go by word, right? So if I hit like Control left and right, if I move my caret from the end of the word to the beginning, it will also say something.
How to fix out of bounds pointer error with grub. Link. Comma document web. How to fix out of bounds pointer error with grub take tag. Document web. E. Capital H. Here's T. E process. Use a fiboonger to remove all. Boot messages.
Okay. Now, I know you can't see what keys I'm pressing here, but I'm basically just pressing arrow keys. I'm doing left and right, up and down. Odilia is able to detect when you're on a new line and read out that entire line. But if you go by one character, then it'll only read out that one character.
This tells your EFI system that there are no EFI entries. To boot into. Don't worry, this will get repopulated later. Remove boot EVN.
Okay.
Boot grub. To remove all EV boot images and all grub configurations, run the following command.
All right. You guys get the idea. I'm not going to bore you with
Quitting Odilia.
sounds of Samantha. That's the voice name. Anyways, that is my very not fast introduction to accessibility on Linux and the Odilia screen reader.
And I actually, you learned something useful out of it, because like speaking is a can be a useful component in an application.
Yeah, for sure. Any questions from the Discord? I can probably
You should share the Discord server.
unmute you guys.
You should share the server.
Share the server?
Share the Discord server
With who?
with this group.
What Discord server?
Odilia?
Oh, yes. Okay. So there is an Odilia Discord, or we are on Matrix. So if you guys are fans of decentralized stuff, feel free to join us there. Or Discord. I will get the links up for you guys. I'll send it in the Discord chat here.
And
Yeah.
Jaden says, bravo, that's awesome take. Great job.
Thank you. I'm glad.
It's a very
Yeah.
niche thing, so most people don't care.
Yeah, and that's the thing. Is like I can only really give one presentation on this, and then like what am I supposed to say? You know?
Well, you could tell us about the challenges that you faced, about optimization, about...
Oh yeah. Okay. I'll give you a quick one because it's let's see what time is it? It's 7:20, so we have 10 minutes.
Yes.
So optimization is something we wanted to do early on, but at first we had no cache at all. And anyone who's ever implemented a cache for the first time knows how big of a difference it is. This is not a 10 times speed improvement. This is like a 1,000 to 10,000 times speed improvement, right? 3-4 orders of magnitude. So when we started out, let's say that you were at heading 1 and you wanted to go down the page to heading 2. What we had to do, and I'm serious, is we had to call out to dbus, which is a separate process. Okay, so you have to wait for a context switch. We had to call out to dbus, ask, okay, what are the children of this element? What are the children of that? We essentially had to do a depth first search for every element in the tree going down until we found it. It took forever. Sometimes over a full second. Over a full second to do one structural navigation. And to be clear, people who use screen readers might use structural navigation, like they might hit H twice, like that, and expect it to just work. That's how fast they're expecting it to work.
I have a question.
Yes.
Is has dbus stagnated, or...
dbus is not growing much anymore. There is a new implementation called dbus broker, which is much faster, but it's still written in C. There are some people that want to rewrite dbus in Rust, but no one has undertaken that challenge, and I am not doing it.
And that's something. The reason why I'm asking, do I get it right that when you want some piece of information, you request some data, you get it back, and then you have to do it again and
Yes,
again.
that's correct.
And I know that in PostgreSQL now you can actually use WASM in order to set a function.
Yes. So we don't have any of those luxuries. We're dealing with C binaries on the same machine. Now, one of the things that I think could be improved is because we have a cache, we can now do all sorts of... so cache... now we're good. Like I said, we're doing thousands of elements per millisecond through... Like once they're loaded in, we can do thousands per millisecond. But without it, we were assuming, because it's in the specification, okay, so the ATSPI specification says there is a collection interface. That interface is implemented almost everywhere. And then you could request essentially a structural navigation. Take me to the next element where, the role is equal to this or this. And the text contains this or whatever, right? It's essentially depth first search from a starting point. Now, even though the specification has the collection interface, nobody implements it. It's there, you can call it, but it will always return nothing. So this is a very broken space. There's a lot of things that are documented but not implemented but not documented. There's so many examples of that. That has been our biggest roadblock, for sure, is that even if we read the documentation, we can still be wrong.
Very, very relatable.
Anyone who has worked with old school C programs and has to interface with them knows all about this. And that's not to say that the people that work on this are being lazy or whatever. The people that are currently working on ATSPI over at the GNOME Foundation are incredible. They're trying to get 100% test coverage right now. That is admirable, and I'm so glad someone's working on it. But they also neglected it for 10 years. Fun fact, this is a fun history lesson, ATSPI started at Sun Microsystems. Then when Sun was bought out by Oracle sacked the accessibility team. And so GNOME took over since then. And so for the past couple decades, GNOME has been in charge of it. Mm-hmm. There's a random fact for you. Just another reason to hate Oracle,
Always has been.
Yeah, exactly. Okay, I don't know if there's any other questions in the Discord chat. I don't think so.
I don't see any.
All right. That's my very long... I should probably practice this presentation a few times and get it down to 20 minutes. I think it would be much more exciting if I was able to do this in 20 minutes.
Yeah.
Yeah.
But it's already great. It's already great.
I'm glad you think so.